Okay, so here's another polynomial division problem. Let's divide 2x cubed minus 9x squared minus 8x plus 26 by x minus 5. So again, we are going to write 2x cubed minus 9x squared minus 8x plus 26, the dividend on the left here. And then on the right, we are going to write x minus 5, the divisor, and then we're going to put in our quotient, which of course will be a quadratic, and then our remainder, which has to be a real number, because, so that's why we're putting it as r and not r of x, because it has to have a lower degree than the divisor, and the divisor is a linear term, so it has degree 1, the remainder has to have degree 0. And then again, we are going to match term by term. We have a 2x cubed and an x. What do we have to multiply x by to get our 2x cubes that we need over here? Well, that's 2x squared. And we distribute it in, and we get 2x cubed, which matches the number of x cubes we want, which is perfect. And then we multiply it by the negative 5, and we get negative 10 x squared here. It's negative 10x squared. And then what do? We look at the number of x squareds we want. We want negative 9x squareds. We have negative 10x squareds. So how many x squareds do we have to add to the negative 10x squareds to get the negative 9x squareds? It's going to be 1, right? We need 1x squared to turn that negative 10 into a 9. So we put an x here because the x will multiply by the x and give us x squared. And that takes care of the 9x squareds. But then the x also multiplies by the negative 5, and we get negative 5 x's. How many x's do we want? I think we wanted negative 8 x's. So we have negative 5, we want negative 8, means we need another negative 3. We need another negative 3 x's. So we put in our next thing, our last thing, which is going to be the constant here, because then we've reduced the degree of the terms to the point where we can't reduce it anymore. We're at degree 0. So we put negative 3 here. That negative 3 distributes in, multiplies by the x, gives us the negative 3x's that will turn those negative 5x's into negative 8x's, and these terms match. And then, last step, it multiplies by the positive, or the negative 5, and gives us a positive 15. Right, this gives us plus 15 here. But we're supposed to have plus 26, right? We're supposed to have 26, and we have 15. So this is not a clean factor, right? X is equal to 5, as you can check, is not a root of this. And we actually can know that just by looking at it, because the rational roots theorem says that any rational roots, and 5 is a rational number, of course, any rational roots of this will have to be factors of 26 divided by factors of 2, and 5 is not a factor of 26. So we would have known this from the start, right? That this isn't going to, or we could have known this from the start, that this isn't going to be a clean factor, right? Factor theorem said that if it were, then 5 would be a root. So we have a remainder. What's the remainder going to be? Well, the output of this process, right? After doing all this stuff, so multiplying this thing by this thing, which we just created, the output of this is 2x cubed minus 9x squared minus 8x plus 15, right? That is equal to this. So if we want it to be equal to that, if we want the left side to be equal to the right side, we have to add a remainder term. What's the remainder? Well, it's whatever we have to add to 15 in order to get 26, which I'm pretty sure is 11, right? We have to add 11 to 15 to get 26. And so this gives us our division statement. This is the division statement. 2x cubed minus 9x squared, 9x squared, minus 8x plus 26 is equal to x minus 5 times 2x squared plus x minus 3 plus 11. This is the dividend, this is the divisor, this is the quotient, and this over here is the remainder. And so just to sort of tie this again into maybe another theorem, we do talk about this in other videos though, but the remainder theorem says that, and this is how we can see it, right? It comes directly from our polynomial division algorithm, says that P of 5 is equal to 11, right? If we plug in x is equal to 5 here, this becomes 0. Whoop, so sorry. So this whole thing becomes 0, and 11 comes out, right? So the remainder theorem basically tells us that if you plug in a number, so a real number to a polynomial, then the output of that is the remainder that you get after you divide that polynomial by x minus the number that you put into it. So and this ties into the factor theorem, right? Factor theorem is a special case of that. If P of 5 is equal to 0, right? P of 5 is 0, that means the remainder is 0. And that means that the polynomial is divisible by x minus 5. So although actually the factor theorem says the opposite as well, right? The opposite direction is really obvious of the factor theorem, right? If x minus 5 is a factor, so we have this, then P of 5 is going to be 0, because you plug in 5 for x, and this is 5 minus 5, which is 0. But the really sort of important part of it, the material part of it, the non-trivial part of it is the other way, saying that if P of some number is equal to 0, then x minus that number is a factor. And this actually follows from the remainder theorem, right? Because it says the remainder, when you plug the number in, is P of 5. So if P of 5 were 0, the remainder would be 0, and x minus 5 would be a factor.